Assalamu alaikum. Long time no see. But anyways, welcome back into a lesson for particle physics, physics 9702. In this lesson, we'll be first discussing 11.1 that serves as the prerequisite for 11.2. And this, by the way, is the topic that we have already covered in O levels as well. But before moving to 11.2, we'll be briefly discussing these topics as well. Starting with the very first objective, that is for alpha particle scattering experiment, which led to the conclusion for the size of nucleus as well as its composition. This right here is the experimental setup for the discovery of the structure of nucleus. We have a source of alpha particle and then a gold foil, and then we have the zinc sulfide detector as well. A stream of alpha particles were projected through this source onto the gold foil, and as a result, the detector recorded the deflections or the alpha particles which were received at certain angle. This figure right here shows the deflection of or the deviation of these particles as well. So it was observed that the majority of alpha particles, they passed through the gold foil with like little or no deflection at all, which suggested that they must not have met anything in their path, right? Which eventually led to the conclusion that most of the space in the atom is empty. Then, as this figure right here suggests, that small number of alpha particles, they were deviated by an angle that is more than 10 degrees. That is, they were kind of repelled while passing through the vicinity of the nucleus, which then led to this conclusion that since alpha particles are positively charged, then nucleus itself or the region जिसके पास से गुजरते हुए they are being deviated, it must also have a positive net charge on it, right? And then we said that a nucleus has a positive charge. While a few of the alpha particles were deviated at certain angle, it is very obvious from this figure right here that very few number of alpha particle almost bounced back. That is, these were the ones which met the nucleus with head-on collision, and क्योंकि इसका नंबर बहुत ही कम था तो it was suggested कि बहुत कम alpha particles जो हैं वो nucleus के साथ जो है head-on collision में आए थे, which led to the conclusion that nucleus is very tiny and dense region that lies in the center of atom, and it is positively charged. And for your reference, this right here is the picture comparing the size of atom, that is the diameter of atom, with the diameter of nucleus. Then the next objective says describe a simple model for the nuclear atom to include protons, neutrons, and orbital electrons. That is the easiest, that we already know that in an atom we have the central part, that is the nucleus, where protons and neutrons reside, and इनको collectively हम nucleon का नाम देते हैं, and we have electrons which are orbiting the atom. Then you have to distinguish between nucleon number and proton number. We know that nucleon are the residents of nucleus, right? So it includes the number of protons as well as the number of neutrons. For an element which is represented with X, this A, which we also know as atomic mass, this is the nucleon number, which is nothing but the sum of proton numbers as well as neutron numbers. And then this right here we have Z, which we also call the charge number, or maybe the number of protons in the nucleus. Or अगर हम किसी natural or neutral atom की बात करें तो we'd say that this is the number of electrons which are orbiting the nucleus. So if you have to find the number of protons and you are provided with the number of neutrons and the number of nucleons, all you have to do is you subtract from number of nucleons the number of neutrons, and you'd be getting the number of protons, which is the charge number. The next we have is understand that isotopes are forms of same elements with different numbers of neutrons in their nuclei. When we have isotope, let's say we have, for example, we have isotopes for hydrogen. Remember, this is what we used to have: 1 1, 1 2, and we have 1 3. This suggests that it has one proton and no neutron, because neutron plus proton is also one, right? This is hydrogen. Then we have one proton and two nucleons, जिसमें से एक अगर proton है तो this means that the remaining one must be neutron. This is deuterium, and the next one we have is tritium, which suggests that we have one proton and then three nucleons, जिसमें से अगर एक proton था तो यकीनन बाकी के दो neutron होंगे. Now these three, they are hydrogen atoms, right? They have same number of proton or charge number. However, they have different nucleon number, which is because they have different neutron number. So when we have to describe isotopes, or when we have to define isotopes, we say that these are the atoms of same elements having same proton number but different neutron number or different nucleon number. The next we have is understand and use the notation for the representation of nuclide. This is what we have briefly covered right here. The next we have is understand that nucleon number and charge, they are conserved in nuclear processes. That is something we have already discussed, but we'll be discussing it again in a few slides, where we'll be discussing the emission of alpha, beta, and gamma radiations as well. In case you have had any confusion, that will inshallah be covered wahan par. The next we have is describe the composition, mass, and charge of alpha, beta, and gamma radiations. And when it comes to beta, we have to cover beta negative, which is nothing but electron, and beta positive as well, which is anti-particle for electron, जिसको हम positron का भी नाम देते हैं. It has same mass as that of electron, but it has exactly opposite charge as that of electron. For that, let's move to this slide right here. This table right here consolidates all we have to know about alpha, beta, and gamma radiations. In our objective that we have previously covered, we have agreed upon a unified mass that will be represented with U, and we had agreed that this is the mass for one nucleon. एक proton का mass या एक neutron का mass, उसको हम U से represent कर रहे हैं. So since alpha particle की composition क्या थी? Helium nucleus, it has two proton and two neutrons as well. That means it has four nucleons. So if I'm to write its relative mass, I'll just write 4U, that its nucleus has total of four nucleons. And then we have beta particle. Beta is nothing but an electron when it comes to its mass as well, right? It is much lighter as compared to the nucleon. So we say, वैसे तो it is around 1800 something, but rounding off, we say that one nucleon is equivalent to almost 2000 electrons when it comes to their mass. So we can just write U over 2000. And then we have gamma. Gamma is massless radiation, so its mass is nothing, it's zero. Then we have their charges. Charge is because of protons in the nucleus, right? Because neutron does not have a charge at all. So depending on how many number of protons were there in the nucleus of alpha, that is in the nucleus of helium, 2 proton, it is plus 2e, where this e is the fundamental charge. That is the charge on proton, that is the charge on electron, which is 1.6 10 raised to the power minus 19. When it comes to beta particle, if it is beta negative we are talking about, we'll be mentioning minus e. If it is beta positive, we'll be mentioning plus e. And then gamma does not have a charge as well, like it is a massless and a chargeless radiation. Then alpha particle are called helium nucleus because we are excluding the orbiting electrons. When it comes to beta particle, they are called fast moving electrons, which are originated from within the nucleus. And then gamma radiations are nothing but high energy or high frequency radiations, जिनको हम short wavelength electromagnetic waves भी कहते हैं. And right, because I said they are electromagnetic waves, they have to have the velocity that is light ki velocity, which is represented with c 3 exponent 8 meters per second. When it comes to beta particle, yes, they are fast moving electrons. Their velocity is 99% of the speed of light. And when it comes to alpha particles, their velocity is almost 5% of the speed of light. But that does not mean that they are slow moving. When it comes to their velocity, it's like 10 raised to the power 7 something, right? So it's quite fast when it comes to their velocity as well, even though it is much less as compared to that of beta and gamma radiations. Then we have penetrating power. Alpha has a huge mass. Alpha has the greatest charge when it comes to these three. Therefore, alpha interacts with matter at a greater level compared to beta and gamma radiations. And because it keeps on interacting with the matter as it keeps on moving, it keeps on departing its energy जिस भी matter के साथ वो interact करता है, right? This is why alpha cannot penetrate through larger distances, and therefore जैसे जैसे वो move करती जाती है for a certain distance, it keeps on, transferring its energy to the particle, and as soon as its energy becomes zero, it vanishes. It comes to rest. When it comes to beta particle, beta has comparatively lesser mass, beta has comparatively lesser charge, so it does not interact with the matter on a level alpha does. And क्योंकि ये ज़्यादा interact नहीं करता and ज़्यादा अपनी energy उनमें transfer नहीं करता, therefore it can penetrate through comparatively greater distance. जहाँ alpha can be brought to at rest with a thin piece of paper, beta can not only penetrate through a thin piece of paper, it requires a certain millimeters of aluminium to bring beta particle at rest. And air mein to it can penetrate through like a certain centimeters. When it comes to gamma radiations, इनका तो charge भी नहीं है and mass भी नहीं है. Therefore, they have quite high penetration power. When it comes to aluminium, they can pass through millimeters and centimeters of aluminium. And when it comes to lead, a certain centimeter of lead is required to bring a gamma particle at rest. Then we have their relative ionizing power. Ionization is जितना वो ज्यादा interact कर रहा है, अपनी energy depart कर रहा है, जिस भी न्यूक्लियर एटम के साथ कांटेक्ट में आ रहा है in its way, उसके positives और negatives को अलग कर रहा है, यानी उसके इलेक्ट्रॉन को dislocate कर रहा है, right? So क्योंकि we have agreed that alpha interacts with the material particles, so alpha has comparatively greater ionization, बीटा की उससे कम and gamma की सबसे कम ionization. Then all three of them affect the photographic film when it comes to deflection in electric and in magnetic field. Um, Gamma being a chargeless radiation, it is not affected by electric or magnetic field. And when it comes to alpha and beta, they are affected by both because they have a certain charge. Alpha has positive charge, so it is deflected towards negative plate. Beta, if we are talking about beta negative, being negative in nature, they are deflected towards positive plate. And if we are talking about beta positive, so being positive in nature, they are deflected towards the negative plate when it comes to electric field. And when it comes to magnetic field, both of them are deflected in opposite direction, alpha and negative beta, right? And वो direction कौन सी होगी, that we can identify using Fleming's left hand rule, which says you point your index finger in the direction of magnetic field, your middle finger in the direction of the velocity of the particle, and your thumb will give you the direction of the force that particle is experiencing. And this right here is a picture which shows कि दोनों की deflection opposite होती है. Wherever the alpha is being deflected, negative beta is deflected in the opposite direction. Of course, if it was positive beta, तो वो यहाँ कहीं पर deflect हो रहा होता. And there's a picture right here also emphasizes one additional feature as well. Alpha is um, gradually deflected as compared to beta, and it is again attributed to the same fact that alpha is comparatively heavier and it has greater mass and charge, whereas gamma is passing undeflected. There is one important thing that should be noted here as well. Alpha के लिए they've mentioned एक ही specific deviation, but when it comes to beta, different magnitude key deviations are being shown in this figure right here. Why is this so? This covers the next objective that is a frequently asked question in your past paper questions as well, kinetic energy. And these right here are the number of alpha particles, or we can say that the intensity of alpha particles, right? Let's say you have a thorium nuclei, right? And it is emitting alpha particles. Jitne bhi alpha particle this sodium is going to emit, all of them are going to have same kinetic energy. That is why you see a straight vertical line at a certain value of kinetic energy. Clear? But when it comes to beta particle, let's assume that we have a thorium atom and it somehow is emitting a beta particle. Energy of that beta particle is not constant. That is, it might be the case that it emits an energy of a certain value, and then wahi same atom can also emit a beta particle with a different energy. And when we plot a graph, this right here is the graph that is for the emission of beta particle. See, this many number of beta particles, this many number of beta particles with different kinetic energy, they have different kinetic energy, so on and so forth. So this right here is the energy spectrum of beta particle. Why there is this changing energy? क्यों fix energy का beta particle नहीं emit हो रहा when जो parent element जिसकी हम बात करें वो same है? While trying to answer this question, it was suggested by, I think, Pauly, the scientist. He suggested that जब भी बीटा पार्टिकल इमिट हो रहा है फिर यकीनन साथ में एक और पार्टिकल भी इमिट हो रहा है and the energy is being distributed between these two. When a beta of greater energy is being emitted, यकीनन जो दूसरा पार्टिकल साथ emit हो रहा है उसके लिए lesser share of energy is available, and जब बीटा की एनर्जी कम है तो यकीनन जो बराबर में पार्टिकल इमिट हो रहा है उसकी एनर्जी ज्यादा होगी. And while trying to identify that particle as well, फिर एक और जो suggestion दिया गया, it was कि जब भी बीटा emit हो रहा है एनर्जी के लिए जो हमारे पास न्यूक्लियर इक्वेशन है वो तो बैलेंस है in terms of its charge and in terms of its mass. तो यकीनन जो particle emit हो रहा है it does not have a charge, it does not have a mass. Later on this particle was termed as anti-neutrino, right, which is represented with the symbol nu. Since it does not have charge, we have charge number as 0. Since it does not have mass, we say that its mass is like even less than the mass of electron. So we say that it barely has a mass. So हम उसको बस 0 से equate कर देते हैं, right? So we have neutron, neutrino, जिसको हम electron neutrino का नाम देते हैं, and we have इसी का anti particle जिसमें हम एंटी न्यूट्रिनो या इलेक्ट्रॉन एंटी न्यूट्रिनो का नाम देते हैं जिसको हम, राइट? नाउ देयर कम्स द ट्रिक. When you see the past paper questions, examiner asks you to write an equation which shows the decay of a parent atom while it is emitting a beta particle. Let's say they have mentioned कि beta positive particle है या beta negative particle है. So they'd ask you to balance the equation. They'd ask you to write the equation. Now, they might not have considered this point while you were attempting the same question in O levels, but while you would be attempting that same question in A levels, you have to be very specific about mentioning the neutrino or anti-neutrino. जिसके लिए the simple equation we have are these two. Whenever a beta negative, that is an electron, is being emitted, always an anti-neutrino is being emitted. And then whenever we have positive beta being emitted, जिसको हम positron का भी नाम देते हैं और beta plus कहते हैं जिसको, always a neutrino without bar, right, is being emitted along with the emission of energy in both the cases. Now, this part right here is because a beta is always emitted from within a nucleus. But then we know that nucleus is made up of protons and neutrons only, right? It does not have electron in the first place. So how come a nucleus emits a beta particle, be it positive or negative? Uske liye, this right here is the justification, and the same is the justification that the examiner asks of you in the final exam as well. They'd ask you to write an equation with the emission of beta particle and you justify it in the sense of number of quarks as well, which we'll be discussing later on. For the time being, it should be enough for us to know whenever a nucleus emits a radiation, be it a particle radiation or a massless radiation, right? It's because the nucleus is unstable. Now, how come the nucleus becomes unstable? Within the nucleus, we know that there are number of protons and number of neutrons, right? So among the nucleons, because they have masses, there is gravitational force of attraction. While neutrons do not have any charge, protons have a charge, that is positive charge. This then leads to another force within the nucleus, that is Coulomb's electrostatic repulsion, that is repulsion between every two protons, right? But the problem is the Coulomb's repulsion is almost 10 raised to the power like 30 something times greater than that of gravitational attraction. And in order to balance that repulsion, there is another force that works between the nucleus, within the nucleus, that is called strong nuclear force. The three forces we have agreed upon so far. Now, the strong nuclear force only works between protons and neutrons, right? It does not affect the electrons which are orbiting around the nucleus. Then comes the fourth force, which is weak force that affects protons, neutrons, as well as electrons. So when it comes to the binding of nucleus, it is not that simple that it is just the gravitational force or it is just the Coulomb's repulsion force. Attraction भी है and then repulsion भी है. For a nucleus to remain stable, जब आप lesser number of nucleons वाले atoms के बारे में पढ़ेंगे तो you would realize that they have almost equal number of protons and equal number of neutrons. लेकिन जैसे जैसे हम heavier elements की तरफ जाते जाते हैं, number of neutrons have to be greater. Why? Because प्रोटॉन प्रोटॉन रिपल्जन बहुत ज्यादा है, उसको बैलेंस करने के लिए न्यूट्रॉन का नंबर मजीद ज्यादा होना चाहिए जो सिर्फ अट्रैक्शन, ग्रेविटेशनल अट्रैक्शन में कंट्रीब्यूट करे एंड रिपल्जन में कंट्रीब्यूट ना करे. बट देन जब हम 80 समथिंग, स्पेसिफिकली 83 से जब हम मजीद ऊपर चले जाते हैं, दैट इज व्हेन द increasing number of neutrons also stops making any difference in the stability of nucleus, and that is when the nucleus becomes unstable, right? And now that it has become unstable, it might be because it has comparatively greater number of neutrons than it should have been for its stability, or it has greater number of protons than there should have been. So now in order to become stable, if it has greater number of neutrons, what happens? The neutron within the nucleus, it decays so that the number of neutron decreases leading towards the stability. अब जो एक न्यूट्रॉन डिके कर रहा है वो कहाँ जा रहा है? बिकॉज हम तो कहते हैं ना न्यूक्लियर इक्वेशन में द चार्ज मास एवरीथिंग नीड्स टू बी कंजर्व थ्रू आउट. नाउ दिस न्यूट्रॉन decays and we get a proton which stays in the nucleus as well as an electron which is negative beta, and this negative beta emits out of the nucleus as fast moving beta particle. And we have already agreed that whenever we have negative beta leaving the nucleus, we always have to mention anti-neutrino for the sake of energy conservation. Now, is this equation correct? Is it possible? Let's see. For this equation to be possible, like on a bigger picture, it has to have equal charge number on both sides and equal mass number on both sides, right? Antineutrino does not have a charge. Electron -1, proton +1, and neutron had 0. So -1 +1 +0, it is conserved, it is 0. And when it comes to mass number, originally we had +1, and after the decay we had +1 +0 +0. So again, the mass number is also conserved. That was for negative beta. That was for electron. Now what happens if the number of protons in the nucleus are greater? Now for the sake of stability, the nucleus is going to emit a particle so that it leads to the decrease in number of proton. In this case, what happens? A proton within the nucleus, it decays and it converts into a neutron as well as a positive electron or a positive beta particle. The neutron stays within the nucleus and this positive beta leaves the nucleus as again fast moving electron. And since we have a positive electron emitting out, in order to balance the energy, kinetic energy, we have a neutrino also being emitted along with the emission of energy. Is this equation balanced in terms of charge number? Yes, it is. You can see it for yourself. Is it balanced in terms of mass number as well? Yes, it is. How does the examiner ask you a question from this topic? They'd ask you to write down the equation for beta decay, or they can ask you to write a statement. What happens when positive beta is emitted out of the nucleus? So you'd write, when it comes to positive beta, you'd mention that number of proton in the nucleus decreases by 1 and the number of nucleon remains the same, or we can say the number of neutron increases by 1, because अगर एक न्यूट्रॉन बढ़ा है तो एक प्रोटॉन कम भी तो हुआ है. Number of nucleon remains the same even if it is about beta positive or beta negative. And if you have to specifically write for beta negative, you'd write that number of neutron decreases by 1, number of proton increases by 1. Or you can say neutron decreases by 1, but nucleon remains the same. I think we have almost covered the prerequisite, and 30 minutes should have been enough to brush up on what we had already known from O level. Let's just see if there is anything that is left. We have discussed their composition, their mass, their charge. Understand that an antiparticle has the same mass but opposite charge to the corresponding particle, and that a positron is the antiparticle of an electron. That we have agreed upon. Then you have to state that antineutrinos, जिनको electron antineutrino भी कहते हैं, they are produced during beta negative decay, and neutrinos, they are produced during beta positive decay, that we have just seen with the equation and with the statement as well. Then understand that alpha particle have discrete energy but beta particles have a continuous range of energies because neutrinos or antineutrinos are emitted in beta decay. That's sorted. Then represent alpha and beta decay by a radioactive decay equation of the form this, that we have already seen. Alpha is understood that since it has 2 protons and 2 neutrons as well, so whenever an alpha particle is emitted from a parent atom, whenever a parent atom gets converted into an alpha particle and a daughter atom, the daughter atom we have has 2 lesser protons and 2 lesser neutrons, or we can say 4 lesser nucleons altogether. And then the last we have is we have to be able to use U, that is unified atomic mass, that is the mass of one nucleon जब भी हमारी mass से related कोई conversion चल रही होगी उसमें, that we can do. In the next lesson, what we'll be seeing is understanding that how many fundamental particles we have. If quark is a fundamental particle, how many flavors of quarks do we have? And when we said that quark is a fundamental particle, तो फिर इससे मिलकर और कौन-कौन से particles बन सकते हैं? So on and so forth. So till then, Allah Hafiz. I hope it made sense to you. the topics we have covered in this lesson.